Welcome to the Institute of Contemporary Art in Boston. I'm Monica Garza. I'm the Director of Education here at the ICA, and it gives me great pleasure to introduce you to tonight's speakers. They're all highly accomplished individuals in the fields of both art and science. So I thought I'd give you a little bit of biographical information regarding the three individuals before I turn over the mic to Lois. On the far right, we have Dr. David Weinberg, who's the professor of astronomy and a distinguished professor of mathematical and physical sciences at Ohio State University in Columbus. He is currently the project scientist of the Sloan Digital Sky Survey, which is creating the largest ever maps of the cosmic distributions of galaxies and quasars. And since 2004, he began collaborating with the artist Josiah McElheny on the design and cosmologically inspired sculptures, which draw on data from the Sloan Survey, Hubble Space Telescope, and on results from computer simulations of cosmic structure formation. I have to read this. This is a lot to read. Of course, the exhibition, Josiah McElheny, Some Pictures of the Infinite, is found on the 4th floor here at the ICA. And for those of you who have not seen the exhibition yet, the galleries do close at 9 p.m., so you'll get a chance to see the exhibitions, revisit them as well after the talk as well. But in that exhibition, there are two works that Dr. Weinberg collaborated with the artist on, and he'll be talking about some of that today. Right here next to me, we have Bang Wong, who's the creative director of the Broad Institute of MIT and Harvard. He's also an adjunct assistant professor in the Department of Art as applied to medicine at Johns Hopkins University School of Medicine. And at the Broad, he led the design and development of the DNAtrium, an exhibition space dedicated to the exploration of the human genome. Bang is also a contributing writer for Nature Methods, and he is a member of the advisory board for Science for the Public here in Boston. In the middle, we have tonight's moderator, Lois Hetland. She is a professor at the Massachusetts College of Art and Design, and she is also the chair of the Art Education Department. She is the co-author of numerous publications. I'm not going to list them all, okay. But including Studio Thinking, The Real Benefits of Visual Arts Education. And she's also the senior research affiliate with Project Zero at the Harvard Graduate School of Education. Lois actively participates in local and national dialogues on arts education. And as you can imagine, her resume is quite extensive. And I love this biographical information that I found on your website, too. You have a scholarship in your name. I love that.
It's the coolest thing ever.
I know.
They gave
Since
me a
2005, there's a scholarship, the Lois Hetland Project Zero Classroom Scholarship, which is awarded annually to a public school teacher to attend Project Zero's annual Summer Institute at Harvard Graduate School of Education. How awesome is that?
That was so awesome.
Now, before I turn over the mic to Lois, I just wanted to thank our co-host for this event, Science for the Public, and its director, Yvonne Stepp, who is here somewhere. There's Yvonne right there. Science for the Public is an organization that encourages public appreciation of science through its programs featuring leading scientists and authors. So thank you all. Hope you enjoy tonight's program.
So is this on? Yeah, I'm on too. Okay, good. Well, thanks for coming. This is a really nice sized group. I hope that, we're planning to have time for conversation, so I hope that it works out that way. I can see you're all just bursting to have your say. We had a debate about whether we should start with David, who's going to be connecting directly to the exhibition upstairs, and then go broader into the idea of science and visualization and the arts, or if we should start broad and then go into the specifics. We decided to go with the direct connection to the work and then broaden it out. I hope you think that was the right decision, because that is what we're doing.
Okay. I have the clicker.
And so David's going to begin, and there'll be 10 minutes of David, then there'll be 10 minutes of Bang. Then there'll be 20 minutes of the three of us riffing off of what it is that comes up around these issues, and then we'll open it up to everybody. At least that's the plan. We'll see. Okay?
Okay.
You're on.
So I will explain the what's going on behind the two works in the exhibition that I had a hand in. There's a 10-minute version of this, and a 1-hour version of this, a 4-hour version of this. You'll get the 10-minute version. This is Josiah at his glass-blowing studio in Brooklyn. And our collaboration began in 2004, though its roots are in 2000, when Josiah first visited the Metropolitan Opera House and saw these chandeliers, and he was very interested in them. He's always interested in things connected to the history and production of glass. These were sort of major productions of one of the big Viennese glass factories in 1965 when Lincoln Center was built. And when he saw them, he was very struck by them as looking like sort of pop renditions of the Big Bang. And he was struck by the historical fact that they were created in 1965, which was the year that the cosmic microwave background, the clinching evidence for the Big Bang, was discovered. So when he got a residency award from the Wexner Center for the Arts at Ohio State, and Helen Molesworth, who's now the head curator here, was the head curator there at the time, he said, well, the piece he wanted to do was something that involved these metropolitan chandeliers, but he wanted to remake one and lower it to eye level so it would function as a sculpture rather than a light fixture, but also to make it a scientifically accurate rendition of the Big Bang. Okay. So and in addition, on the artistic side, you can see that the Met chandeliers are this kind of odd hybrid of 19th century cut glass opulence and Sputnik. And so for Josiah's piece, he wanted to remake something that was more a sort of pure 1960s object at the sort of height of modernism. So he had the notion that glass pieces could represent galaxies, lamps could represent quasars, but he was aware of the problem that this looks like an explosion of stuff into space, which is how many people think of the Big Bang, but is not actually how we think of it scientifically, where the Big Bang is really an origin of space and time itself and an initiation of the expansion of space. So in talking through this the first time, we came up with a solution which, to make this more scientifically accurate, was to let distance from the center represent not spatial position, but represent time. So that the center of the sculpture, and this was Josiah's drawing of what he imagined this thing would eventually look like. This would be sort of the Big Bang itself. The outer edge would be the present day. And as we went outward, we would be going forward in time. And one virtue of this is that this central sphere, which you need so that you can actually construct it, turns out to then have a natural representation to represent one of the most important transitions in the universe when it goes from being transparent to being opaque. And that happened about 500,000 years after the Big Bang. So this becomes interpreted as something we call the last scattering surface, that epoch of transition to transparency. And then with that notion, we could start to put in lots of scientific information about what astronomers have learned about the history of the formation of galaxies and the expansion of the universe. So this is the first fruit of our collaboration. It now belongs to the Tate Modern Gallery in London. And it looks a lot like this sketch, but now there's actually a quite detailed mapping between these rods come out at random angles, but their length then determines what epoch of cosmic history they correspond to. So outer edge corresponds to the present day. Somewhere in here corresponds to several billion years ago. Back here is sort of 14 billion years ago. And depending on the length of the rod, we then make different choices about the kinds of galaxies that are present, the kinds of lamps that are present, that correspond to what astronomers have learned about the history of the universe. So galaxies come in two main types. There are ones that are flattened like disks. Here's an edge-on view of one. So the Milky Way is something like this. There are other galaxies that are sort of elliptical blobs that basically appear round from any side. So they're spherical. So they're represented in the sculpture by disks and spheres. But there are different sizes of them, so we're able to encode things about the average growth in the size of galaxies and the diversity in the size of galaxies. And galaxies are also clustered. They don't appear randomly in the universe. This is a map of the distribution of galaxies from this project called the Sloan Digital Sky Survey. The Earth is here. Every dot here represents a galaxy. So every dot corresponds to a collection of 100 billion stars held together by gravity. The outer edge of this map is about 1 billion light years away. So light's been traveling 1 billion years to get from these galaxies to us. The color of the dot corresponds to the color of the galaxy itself. So red galaxies are made principally of old stars, and bluer galaxies still have a lot of forming young stars. And you can see there are these filamentary patterns and clumps, and we tried to represent that kind of structure in these clusters of glass pieces in the sculpture. So zooming out from the middle, so here you see the reflective sphere corresponds to that last scattering surface. Close to it, you see small clusters, a few pieces. They're all disks, because we think disk galaxies formed first, and they're all small. And then as you move further out, you start to build up more complicated clusters. Some of these elliptical galaxies start to appear. We think they actually happen arise when disk galaxies merge with each other and tear each other up gravitationally and disorder the orbits of the stars. And the sizes grow as well. There are also lamps that represent quasars powered by gas falling onto supermassive black holes, and the brightnesses of the lamps and the frequency of the lamps also traces what we've learned about their cosmic history. As we zoom still further out, we're now seeing closer to the present day. We're seeing more of these structures that we see in these maps of the distribution of galaxies were less prominent in the past because gravity had less time to act and less time to pull things together. And finally, in the present day things, we get these kind of complicated filamentary structures. So this piece is titled An End to Modernity, and that title connects to a sort of whole different theme of what's going on in the sculpture related to the sort of transition from high modernism to postmodernism in the 1960s. But that's the basic scientific structure behind this. We worked on 2 subsequent pieces. This is one of them. It's in the Phoenix Art Museum. And in this one, this last scattering surface should actually be represented as something that glows because it was hot. And so in the second time, we decided we'd mastered the outer parts, so we'd actually make this glow, but glow in a way that corresponds to maps of this cosmic microwave background. So this encodes information about the small imperfections in the early universe that ultimately led to the formation of galaxies and all of that structure. But as soon as Josiah talked about making more than one sculpture, I started to needle him about an idea that ties to more speculative themes, but of contemporary cosmology, in which there can actually be multiple universes. So this theory is called inflation or eternal inflation. And I gave him an article by Andre Linde, who's one of the, he wasn't the inventor of inflation, but was the inventor of this kind of multi-universe version. And this article has actually some very evocative drawings in it of these different bubble universes that separate from each other, people separated, in looking at their separate universes. But what makes this idea particularly interesting is that you could have multiple universes, multiple big bangs, but in which there would actually be sort of different physical laws, different strengths of gravity, or different masses of protons, or different levels of initial structure. So things could actually be quite different one universe to another. So that rather than just having multiple copies or multiple realizations of our own universe, we could actually play around with different rules for these different universes. So Josiah and I had the fun of trying to decide how many universes to make and how to make them. This is one of the diagrams from when we were sort of midway through this process. And these are the five things that appear as island universe. This is, so now you'll see it in the gallery upstairs. This is as it was at its original exhibition at the White Cube Gallery in London. This sculpture here follows basically the same rules as our very first one. So this could represent our universe. It's a little smaller in size than the first one we did. But this one is the one we called heliocentric, for at least representing something that is connected to us. And then each of these others varies something about the properties of the universe. Here is one in which things only form late, so you'll notice that there are no short rods here. You only start to get galaxies and quasars out close to the present day. This is one in which there is a change in the ratio of dark energy and dark matter in the universe, with the result that things form early, but they can't then grow, so we continue to just have disks and we don't develop the big structures at the outside. This one, it's hard to actually come up with a theory that corresponds to it, although arguably there are some, but mostly, this shows a universe which is very far from the kind of isotropic one that we see, and in which structures only formed in some band, as though this itself, the whole universe, is a kind of scaled-up version of an individual galaxy. This piece was also exhibited at an exhibition space in Madrid. That's a sort of crystal palace-like structure. The exhibition space so the building was from the 1860s, and these kind of 21st century replicas of 1960s objects in this 1850s building. I unfortunately didn't get to see this exhibition, but I gather it worked spectacularly well. And it was out in a public park, so people could just wander. They would see weird stuff in here, and they would sort of line up and go in. The last thing, so there's another piece in the show that is the most recent thing that we've collaborated on. We sort of thought Island Universe we were done, but the Sloan survey is done using a telescope in New Mexico. We have to measure distances to large numbers of galaxies, and to do that efficiently, we use these plates. This plate would be about 3 feet across. And we drill holes at the locations of all the objects we want to measure distances to. Those holes are then plugged with optical fibers, which are then fed back to an instrument on the back of the telescope and used to do the measurements we need to get distances and make three-dimensional maps like this one. And so I had sent Josiah one of these as a present, just because I thought he would like it, and he did. It stuck it up on his studio wall. And eventually, this turned into a piece of its own, in which basically this top here is a remade version of one of these plates. And now the things that hang down from it are not sort of random galaxies, but the thing that falls from each hole is a representation of the galaxy that the Sloan survey observed through that plate in that region of the sky. So we see the kind of three-dimensional structure in this little core sample through the universe. The quasars are very luminous, and rare, so we see them mostly very far away. Here we have the kind of normal galaxies. Here we have the brighter galaxies, which we see at larger distances. So there's some mapping as you go further down here. You're going further away from where we are observing from up here. So that's the structure of this piece, which is called A Study for the Centers Everywhere. And we could talk more about the title later if people are interested. I'll stop there.
Great. Well, it really feels like we ought to pause and just sort of settle a little.
You should just go up and look at them.
Okay.
They're much better than they are in slides.
Should I go?
You should go.
Okay. So I work at the Broad, and it's an institute for biomedical research. And research at the Broad involves deciphering all the information encoded in the human genome and understanding the genetic variations and its role in disease. And my job there is partly to think about clever ways that we can represent the data for the research for analysis purposes, but I'm also involved in the outreach project and also our artists in residence project. So I thought for today, I would describe 3 reasons why we might want to represent scientific information visually to sort of set the stage for discussion. And I think one of those reasons is for exploration, why we want to represent data for trying to gain insights into data. We can also represent scientific information for a purpose of explanation, to explain science to our peers or to the public. And of course, for artistic expression. I think when we represent data for the purpose of exploration, it's characteristically different than trying to explain data that information that we already know. And it involves not emphasizing any one aspect of it, but trying to provide an overview so that you can see patterns. And patterns is really the essence of data exploration. And our eyes are really good at seeing patterns. These 4 sets of numbers that you see on screen forms what's known as the Anscombe's quartet. And it's a beautiful illustration of why we might want to visualize numerical data. So when you look at this table of number, nothing really stands out. And when you apply statistical metrics to it, they're nearly identical. They have the same mean, the same variance, they have the same linear regression, and 16 other metrics that are commonly used in statistics. But when you plot these numbers, you can see at a moment's glance they're wildly different. And this is really the power of visualizing numerical data for the purpose of exploration, because it affords us a penetrating look at the structure of data itself. So using visuals to explain science is also very useful. And through the images and pictures have played a very important role in the advancement of science and medicine in its history. But when we explain information through visuals, there is quite a bit of artistry that's also involved. This exhibit here is called a data stream. It's part of this exhibition space of the Broad called the Dean Atrium. And the Broad makes much of the data it generates publicly available. And what we wanted to do was to take that same data and display it on screens facing the lobby, but also facing the street here. And I'll show you one of those panels. The human genome is made up of 3 billion letters long, genetic letters. And you might have heard these stats that between any 2 individuals we're 99.9% alike, which means that there's a spelling difference every 1,000 bases or so. And this collection of spelling differences between any 2 individuals make up makes up what's called the genotype, our genotype, and it describes our sort of risk for disease. So what you're seeing here is the genetic variation being read from a gene chip, and then it's subsequently mapped to the corresponding position on the chromosome. The human chromosome, we have 23 pairs of chromosomes, and those genetic variants are then mapped to the chromosome. So over time, what you see emerge is this sort of complex genetic fingerprints of an individual. And the study that I'm showing you here is from a study called involving HIV elite controllers. These are individuals that are very important in the medical community. They're individuals that have been exposed to HIV but do not develop AIDS. So by looking at the genetic underpinning of these individuals, we can see the mechanism for HIV infection. But you know, that raw data I just showed you is, this is the raw data behind the story I just told you. And I think it's this process of deciding what to show and how to show it is very important in designing explanation of scientific information visually. And I think that this is where the artistry sort of comes into displaying scientific information. So, you know, another reason for portraying scientific information visually is for artistic expression. And the image on the left is from the exhibit upstairs. And as David described, there is an encoding of information in this piece. And I think that when we design artistic piece that captures scientific information, there's a sort of a continuum of directness or literalness, how accurate is the scientific information being captured. And what I'm showing you on the right is a piece at the DNA called the Phylogenetic Mobile, which I'll explain. This is a type of diagram called a tree diagram, and it's commonly used to display phylogenetic or evolutionary relationship between animals. And so, for example, the elephant and the manatee evolved from a common ancestor. And what we have done with this is we've taken this phylogenetic tree and turned it into a phylogenetic mobile. And this mobile contains about the 35 mammals whose genome has been sequenced. And by giving form to this information, you see interesting things that come out. For example, that the cow is actually more related evolutionary to the dolphin than it is to the horse. And in this portrayal, this is the full-scale piece of the Broad. In this portrayal, the edge length, the length that's hanging down from the mobile, is estimate of evolutionary time, and that's been precisely preserved in this piece. And I think as an art piece, people will see different things in it. But as you see this thing move, you can see that it's clearly divided into sort of 4 quadrants, and that reflects the fact that mammals have evolved in these 4 distinct branches. And so these different reasons for visually encoding scientific information can be sort of put on a continuum like this, with exploration on the left, explanation in the middle, and artistic expression on the right. And you can think conventionally that scientists tend to do the things on the left to do sort of the number crunching, and they do the explanation of the science, and the artist creates the art, and they tend to be more on the right side. They do some explanation, but this is, I think, not such an interesting way of looking at things. And I think if you can try to bring the artistic process into the science and the scientific process into the art, it might be a more sort of interesting mix of things, because the process of science is not so different than the process of art in some ways. Scientific discovery doesn't happen in a eureka moment of revelation. It sort of goes in spurts where successes are typically followed by failed experiments, and art pieces don't come about in a flash of inspiration either. They sort of take time to mature, and if you talk to artists, they talk about these sort of sparks of creativity followed by these periods of the loss of imagination, and art pieces take time to mature. So I think that bringing these things together can provide some interesting mixes. This picture here is an art space that we created where we've actually literally embedded a studio inside an active working lab at the Broad, where one of our resident artists was painting on one side of a lab bench and research was going on the other side. And the intention is really to create this environment for impromptu exchanges of ideas. And the artist's ideas, worldview sort of comes through his or her art. And I think as scientists, they see the world differently. And at the Broad, if you talk to someone who studies the genome, they will tell you that DNA is at the center of the universe. It's the blueprint of life, and it's the center of all things. But if you go down 3 floors to the 3rd floor and talk to a chemist, they say DNA, that's just brick and mortar. And the thing that really matters are small molecules, small chemicals that are firing neurons and things, and that enables us to think and have conversation and have thoughts. So I think that by having artists and scientists working closely together, we can really sort of enrich and enhance the richness and complexity and dimensionality of all of the content we create, either individually or together. So I'll end it there with that.
Well, I'm glad I sat in the middle. I hadn't really made it clear in my own head that you were working with these giant things and you were working with these little nano things. And I sort of think about the mind, and it's kind of in the middle. It's really interesting to hear you talking about the, bringing the different perspectives of different disciplines together, and that they're going to identify different things as the salient information, the thing that matters, the thing we really ought to be looking at. And my own research has identified 8 what we call studio habits of mind that artists think in. And we were very careful not to say that these had anything to do with any other disciplines. We found them in visual arts classrooms, and this is what we could demonstrate back to the evidence that this is what the art teachers were teaching. But previously, arts advocates had been making all sorts of claims about the relationship between art and how it makes you smarter in other things. And we had done a bunch of research on that and demonstrated that the claims far exceeded the evidence. So we were going to be extremely careful about what we were asserting about the way an artistic mind works. But as you talk about this, it's very, for example, observation is one of the studio habits of mind. And it's pretty easy to see that there's scientists observe too. And envisioning is another of the studio habits, and scientists have to envision too. And when you look, it is really easy. And in fact, people have started using those habits in the service of other disciplines. But I think, okay, there's so many things to talk about. I'm just going to ask a question here and see what you guys think about it. So when a scientist represents a scientific idea visually, how is that different from an artistic representation? I mean, you started to talk about that in the, but I'm thinking about, like, let's say that observation is a sophisticated habit of mind that the scientist has and that the artist has. So is there anything different about the habit that the artist has or the habit that the scientist has? Or are they exactly the same and it's just a question of focus? What you're looking at, maybe. Do you have an idea?
I think there's an expectation when scientists represent information visually that the reader would decode it in the way that the author intended it to be decoded. And I think that's what makes an effective visual communication in science. There's the, it's not just based on the expressiveness of the author, but effectiveness also depends on the reader to be able to decode exactly what the scientist intended the piece to be decoded. And that transfer of information needs both parties to be keyed in to that graphical representation. And I would say that this encoding and decoding is perhaps more lenient in a very positive way when it comes to art for artistic purposes, because it allows for multiple interpretations, and I think that scientific visuals have a much more limited number of interpretations that are maybe quote-unquote correct.
But then within the field of the visual arts, we've got designers and we've got fine artists. And so fine artists are like, they have more freedom to, I mean, it seems like designers are much more also trying to get the interface of the cell phone so that that icon is just going to intuitively read as what it is I want you to do with it. So it feels like there are kinds of artists who are much closer to a scientific intention in that way.
So I would say that graphic designer and industrial designer, the driving force behind their work is more or less utility, and their work serves a purpose. Typography serves a purpose to communicate a piece of information, for example. And industrial designer working on those cell phones wants to map it to a certain way that's, want to map the user interface in a certain way that's easier for us to use. And there's a practicality aspect to that type of design work that it's, fine arts, I think, serves a different purpose. And utility is perhaps only one part of it, whereas the driving force in other design disciplines.
So I agree with your take on things, that there's it would vary from artist to artist, but often a goal of the artwork is that it will be decoded. It will inspire different reactions from different viewers, and the in terms of how this is played out in the kinds of things that Josiah and I have done. There's a quite detailed and mathematical background that goes into the design of the sculptures. And if you want to know about that scientific background, you can hear me give a talk, or you can read some things that there are places you can go to find that background, but you won't find very much of it on the wall of the gallery. You'll find a little bit. It'll say it's inspired by the Big Bang or something. And so at first, I found that disturbing because my mode is very much the sort of explanatory one Bang was talking about. If I draw pictures or make plots, I'm trying to convey something, and I do want it to be decoded in this way. And so it was, and I think, and to Josiah, it was very important that there be this scientific detail encoded within the sculpture, but it was not actually important to him that that people have that as background to see it. He didn't object to them having it, but he was happy for people to come to it and to sort of be able to tell that there was complexity there, to see that there were both patterns and randomness in a way that was kind of difficult to tease out, but not necessarily to unpack that into the same rules that went into or the same motivation that went into generating it.
So artists are playing a little fast and loose with because it's a different system. I mean, it's
a different goal.
Yeah, there's a more metaphoric kind of. I mean, I love this notion of the end of modernity when we're talking about, in the modern era of art, we're thinking that. I mean, the idea was everything's there in the work. You just need to read the work, and then you get the work. So you have all these labels that say Untitled 3 or something like. That's as much information as you get because it's all supposed to be there in the frame. But in the postmodern era, the idea of multiple positions or multiple readings is even further expanded. Mm-hmm. So, I mean, he was actually getting at that in that piece?
Yeah, so part of in terms of the title, right, so a lot of Josiah's work is related to modernist design or modernist architecture, as you'll see in other pieces like the Czech modernism piece in the exhibition. But he sort of locates in the mid-1960s the kind of end of this modernist ideal of you just gradually strip things away and make something that is purer and more idealized. And then the mid-1960s is when, pop and op and conceptual and other things start to just explode that whole framework and go into many different directions. And so this historical moment was something he was trying to capture, and on the one hand doing this very much modernist style piece, but that has this kind of explosive, fragmentary sense to it.
Yeah, I mean, this speaking from, or the permission that artists have to sort of tackle things from multiple disciplinary perspectives is, I think, fascinating. It's like you don't really have to get it. You can sort of get in on it and then go ahead and explore it. I keep thinking of Mark Dion, who's an artist who has done, he sort of shadows various scientific practices, but he went to the Thames and did a whole excavation on the banks of the Thames, and they had all the tables where they were washing and labeling and putting all of those artifacts together, but it didn't mean anything. He would just put together these little pretty displays. So he was sort of, and very intentionally, using the scientific method as sort of a comment on itself that led someplace else. So I guess it really does feel like it's the purpose that is where things start to diverge or converge?
I think in this idea of leading it to leading somewhere else is a nice idea, because I think that when I was putting my slides together, or these concepts together of having this continuum between exploration and artistic expression on the ends, I think just hearing what Dave was just describing about encoding all of this scientific material in the pieces, but Josiah wanted people to see these things sort of by accident in a way, that there's this randomness and that there's order and it's just not chaos. In some ways it's inviting exploration, and I think that's really the value of the art pieces, is inviting more interpretations, and in some ways it's where scientific explanation is just giving you an answer. The art is, in this way, continuing to ask questions, and by inviting these multiple interpretations, I think it's continually to invite question, and then to think of it, I mean, I think this perpetuation of questioning is what's really going to be beneficial to science, because science is really an effort of asking the right question, and this artistic practice in science, I think, is helpful in that way.
It was, I stumbled onto a nova about the development of the telescope. I think it was a nova. It was on public TV, so I figure it was a nova. But it seemed as if there really is an awful lot, like the development of the science is closely tied to the development of observation and what we can see. And are there other, like they were talking about I think it was the quasars, that they looked like a funny little thing with a haze around it, and they thought they were a certain kind of star, and then with the development of the optics, they could figure out ultimately that they were more galaxy-like or more.
Well, so I mean, I think many areas of science, it's certainly true in astronomy, are the advances are driven in large part by advances in the underlying technology, and so as you learn to build bigger mirrors and shape them better so they make better images, it just starts to allow you to investigate whole fields that you couldn't before. Bang and I were talking earlier at the Broad, and saying that the projects that all the DNA sequencers that did the original 10-year human genome DNA project have now been given away to high schools because they're so obsolete 10 years later, and you can do things so much faster. And so, for instance, and the Sloan survey is able to happen because of these advances in fiber optic technology and digital detectors and so forth. So, I think one of the So the notions of progress in science and in the arts are radically different. And one of the good things about being a scientist is that as the technology advances, it almost always enables something new. So the result is, even if you don't have any particularly good ideas, if you wait around, stuff gets better and more things come in, and eventually you actually make progress and you come up with some good idea. So I think it's much harder for the artists.
I don't know. I think it's very similar in some ways. You just keep looking at stuff, and eventually you're going to see an idea. You're going to see a connection. It's fascinating how, in both cases, perception is so closely tied to thought. And I think there's a real tendency of us to try and say, oh, that's just looking and seeing, that somehow perception is separate from the idea of thinking, but it's not. And as an arts educator, that really excites me, because I think as people begin to understand the connection between perception and thinking, therefore ideas, that it's harder and harder to write off the arts which enhance someone's ability to see.
It's also not just visual perception as well. I think that in some cases, the most effective of these kinds of visualizations and visual metaphors that of the sort that Wang was illustrating, actually give you not just a visual sense, but an almost physical sense of being able to feel, how this star behaves or how this supernova behaves. That sometimes does, having that sort of physical intuition sometimes does actually allow you to, reach to some insight that you didn't have before. And I think part of being trained as a scientist is sort of getting these kind of intuitive feelings about many of the processes that matter going on underneath. And there's actually quite a lot of work now with, I don't know about a lot, but there are some people who are looking at auditory ways of encoding information and listening to data streams. Because in fact, we have whole ways of processing auditory streams that can bring out things different from visual streams. And so there's, I came across some interesting stuff a couple of months ago about how people are trying to encode these data streams so that you can listen to them with headphones and pick out things that are going on. So.
Well, and it's interesting that in the visual arts, sound art is now something that a whole number of visual artists are doing.
Right.
So the distinctions are breaking down within that field as well. How did you and Josiah find each other?
We found each other because my wife is an art historian and the art history professor at Ohio State. And so, through her, I was quite good friends with Helen Molesworth, who was the head curator at the Wexner Center at the time and who has known Josiah for a long time. So, when he said he wanted to do a piece about the Big Bang, I was the natural person for Helen to ask. It would probably have ended up at me anyway, but it sort of fell in naturally that way. I do think that I think it helped the collaboration that the most important thing was Josiah is just very smart, and he was very interested in learning the science and using it. But it certainly helped that I have enough experience with the arts that I at least had sympathy with. I had some sense of what he was trying to do and was sympathetic with that. And I like contemporary art, and that made the collaboration much more natural, I think.
But there was this sort of generative tension that you were feeling about the accuracy of the depiction of the data.
Well, so it was interesting how that played out. So I'll say, all I knew when I met Josiah the first time was that he was an artist, he worked in glass, and he wanted to make a piece about the Big Bang, and he wanted to be scientifically accurate, and I thought, good luck. Right? And so the key thing was in this, first sort of 3-hour lunch, he showed me the stuff about the Met Chandelier, showed me the drawing, we talked through that, and we talked about the expanding balloon, and then and I think I said, well, you could do this thing about having this represent time. And I thought he would probably say, yes, that's a very nice idea, can we get back now to this? But no, he immediately liked that. And the result was, we then had, once we settled on that notion of distance representing time, it was then the case that the more scientific information we put into the sculpture, the more aesthetically rich it became. And I think, it's only sort of in retrospect that we understand how much that was true. But there was remarkably little tension between the scientific accuracy and the aesthetic goals. And it was just as often, Josiah saying, no way, I really don't want to, is that really the right thing to do? And me saying, you don't really need to worry about that, as the other way around. So I would say that the important thing is finding some structure such that putting in the science makes it aesthetically better, and then the tension isn't particularly there. You do have to be willing to let go at some point and say, this is metaphorical or idealized, but it actually worked out pretty well.
That idea about time and distance. William Kentridge did the Norton lectures at Harvard this year, and I don't know if any of you saw them, but in the third lecture, he does a wonderful little riff on how film is actually he takes the film and shows you how many sprockets there are per second, and shows you that film is in fact a physical manifestation of time that then gets turned into time in the projection. And so those are online if you're interested in seeing it. So this is the way it works when it goes right. But are there ways that this can go wrong? I mean, as it all sounds kind of lovely, but what if when the scientists and the artists get together, it's not just that they don't get along, but that the work is somehow bad, whatever that means, like misleading or not as good, or the science is compromised or the art is compromised, or do you have any examples of, have you ever seen that happen?
I think there's, I would describe an unsuccessful relationship as being when the scientist thinks that the artist can't understand the science that the scientist is working on. And that's happened before. I don't have the time to describe my work to this artist. And that type of reaction certainly happens. And I think you had a very special relationship working with Josiah. And I think that there was an idea about being literal in the science and being somewhat loose with the art. Mm-hmm. And that has to come to some sort of common ground. And I think when it doesn't, there's this tension that does get created. I'm speaking as an observer of watching artists and scientists working together, so I haven't experienced it myself.
Yeah. I know that I was saying earlier that to these guys that there's a film that was done in the 80s, I think, called A Private Universe, and it was done at Harvard. They went to a Harvard graduation, and they randomly selected graduates in their gowns and their paraphernalia and all that stuff, and professors, and they asked them about either the reason for the seasons or the phases of the moon. And 21 of the 23 randomly selected Harvard graduates, when asked, had these screwball answers. And in fact, 21 of them thought that the reason we have seasons is because the sun is closer to the earth in the summer. The reason is really that there's a slanted axis, and it has to do with slanting of rays and the amount of sunlight that is heating the orb. Am I
Yes.
close? There's a big chance. Okay. But as they were exploring that, and they were exploring, some of these people who were there were physics majors and were science majors, some were English majors, and yet they all carried around these misconceptions. And I think they ultimately traced it back, at least in part, to a diagram that is in most science textbooks that shows an elliptical orbit because it's in perspective with the Earth, or with the sun in the center. Yeah, and the planets going around it. And it really looks like the planets must be further away at certain points in the ellipse. And that, if you take that and you couple it with the knowledge that we get as little kids, that when you're close to a heat source, it's hotter, like don't touch the stove, it reinforced something. And then, so I think that's another way it could go wrong, is that rather than clarifying the information, it could reinforce a misconception that holds us back from deeper understanding, potentially. So I don't know, you seen any?
Oh yeah, you often find, right. This more relates to the explanatory, particularly the pedagogical aspects where, you're trying to come up with some visual demonstration of something, and sometimes it just doesn't work. And I think, and an issue there is just, part of the training of a scientist is you get pretty good at seeing something in some fairly abstract form, like a set of equations, and understanding what it means. And then, you go try to explain it to people who haven't been trained in that for a long, long time, and it's easy to do a bad job. So,
I know when I see something visually that's complicated and I don't understand it, I just start looking at how beautiful it is and stop worrying about whether I understand it. And I do think that that's a trip up potentially too. It may not be. So let's take the last couple of minutes and open it up to you. Yes.
So I'm probably not going to articulate this very well because I've only been thinking about it for 3 or 4 minutes. But we're kind of a weird place in a conversation about science in the United States right now, in that for a long time there was this perception that scientific progress was unambiguously good and that we were moving toward some sort of better understanding of truth, if you will. My guess is that almost everybody in this room continues to hold that view, but that's not universal, at least in this country, so much anymore. And there is an increasing set of people who believe that science is, if you will, one idea of how to interpret what's going on around us, and that there are other ideas out there competing for explanatory or at least satisfactory power there. Art intrinsically is open to multiple and sometimes competing interpretations, right? And so I'm wondering whether there's some thought that by marrying science and art, that there runs the danger that we are giving, if you will, unintended support or credence to the idea that that science, like art, is just one idea about how things work.
How dangerous. Oh
Yeah.
dear.
I mean, I think there's also a perception that science is very clean, and it's and that experiments are really clean, and when we get data, it's data. But in fact, science is very dirty and it's gritty, and there's this idea of the quality of data, and not all data is created equally. And in those situations, there's a lot of interpretation that happens, and more and more so, computation, computing on data, becomes a bigger part of science. And when you do that, it gets further and further away from the original material, and there's layers and layers of interpretation that happens. And I don't think you need to bring art into that to create that ambiguous space. It already happens.
It's interesting, though, I think, because, I mean, where I immediately went was we're affirming that creationism is as scientific. It's just a different scientific kind of explanation, or that we should be teaching creationism as much as we should be teaching science. And it's like creationism has to do with a religious belief, and that should be taught through those religious beliefs, but as an explanation of it's not in this, it's apples and oranges.
I had the same thought about creationism, because
Did you?
when you were asking that question, and Eric Lander, who directs the Broad, says that we should not be afraid to say the E word, which is evolution, at the Broad. And part of the creation for that phylogenetic tree was, in some ways, that's evolution at work. And we're not saying it, we're not talking about evolution, but that is sort of the Mother Nature's lab notebook on display, essentially.
So I agree that this is a big issue in the United States now, and it's definitely, I think it is one thing that scientists are rather defensive because, we do think that there are things that are special about science, and in particular the sort of testing against observations and experiments from nature, and we want to preserve that. I agree that there is some risk in the sense of, if you diffuse it out, there is some risk to making it, just another thing. Overall, I think it's a risk worth taking, but I agree it's there. I think that from the point of view of art, science is a huge part of human culture, and has a huge effect on the world. So I think that actually makes it a quite natural target for art, in the same way that politics and social relations and so forth are. And I think it actually, overall, I would say science appears surprisingly little in art, given its overall place in human culture. And that may have to do with the fact that the training of artists and scientists is so different that they don't communicate so easily.
Yeah, they don't hang out across the hall like they do at the Broad. Road, excuse me. Gosh, way in the back, yeah.
I almost have the other flip side of that question in that I'm trying to figure out where does data depiction end and where does art start? Because as you're showing the mobile, phylogenetic mobile, that to me looks like that's a cool way of depicting that data. Is a GIS map, the Geographic Information System map, where you can layer lots of data and make pretty maps with lots of colors. Is that art too? I mean, it's kind of interesting way to think about it that way too. You have any comments?
I think it's the purpose and the audience makes a big difference, and in those cases, I think the mobile would be towards the artistic expression rather than an explanation. If I were to give an explanation of the phylogenetic tree, I think I would portray it differently, and so I think your question was about this sort of continuum between data display being for the pure purpose of maybe exploration or for explanation versus artistic expression, and I think you would have to judge it based on the message of the piece and the purpose of the piece, and whether that gets decoded in that same way by the readers.
The founder of Project Zero at the Harvard Graduate School of Education is Nelson Goodman, who is an esthetician. And he wrote a book called When is Art? I mean, he talked about the idea that we're asking the wrong question when we say, what is art? And it sounds like we're participating in that right now when we're thinking, what is art and what is science? He says, if you take a pebble from the driveway and you put it on a pedestal in a gallery, the pebble becomes art. But when the pebble is in the driveway, it's not art. So it has to do with the occasion, and that wraps all around the purpose, the context, and the audience. So, Jasper Johns was doing all sorts of maps, but those clearly, we weren't worried about trying to come up with the answer to that one. But it's a fuzzy distinction.
But I think it does largely come down to this question of how much of the purpose is explanation and how much is inspiration. And sort of connected to both this and the previous question, I would say what science gets out of this collaboration, of this collaboration with art, I think is basically a chance to get out in the world and to actually make contact with a much broader audience who maybe doesn't care about interacting with it in the way that the scientists do, but who nonetheless can find it interesting and inspiring, and that so there's a whole range from people who want to do science to people who want to take science classes to people who are interested enough to watch it on public television, but to people who really aren't interested in it as science, but when it actually comes out and takes visual form or auditory form that they can directly experience, it's a way for science to enrich lives in a way that it otherwise wouldn't.
If science succeeds, if these kinds of visual representations of science succeed, then they answer a question that you wouldn't even have been able to ask. It's like all of a sudden you get in on something that was beyond your ken before, and that can generate questions. But I think art is provoking a conversation. I mean, it's like you have these multiple readings, and it seems like in and of itself, it's a complex conversation. So it's just a different way of talking about what the difference in the purposes. Yeah.
I like the idea that the viewer might actually take either the artwork or the scientific diagram and go beyond what the producer, what either the artist or the scientist put together, because they may see something else. There's an article in the Sunday New York Times about a musician who created a piece and turned it over to a cellist who then adapted it himself and the composer didn't recognize it. That whole concept that you can take something that's created and move beyond what was even intended.
But I think there's a difference. It's like there's a different starting point for the moving beyond. It's like with the scientific representation, the moving on it's like, okay, I get that enough now. so I can go someplace else with it. With the art, it's sort of like just opening it up and going by. You're shaking your head. Do you think that that's wrong?
I'm shaking my head because I think that different people take in information in different ways, and I think art and science are equally inspiring.
Mm-hmm.
And I think the one used exploration, explanation, and expression. And I kept thinking about what also is out of those two things is the next thing, the inspiration that comes either from elegant or inelegant science, or something that's expressed visually. And what does the participant in that, how does the person who's taking it in incorporate it and move with it in whatever way they need to with their life? So I think
Yeah.
the actual question of art or science is not a valid place to start. I think, assuming when we're young and we're starting to go to school and thinking about education in this, we all start doing art way before we start doing science. Yet somehow, by the time we get to first, second, or third grade, we've been identified as either the scientific type or the artistic type. And somewhere around third grade, we decide if we're an artistic type to stop paying attention to many of us. Not, there's a rare person who has all of it, but I think when we decide somewhere that we're the artist, we stop thinking about being a scientist. And the scientist also gets to a point where they're the smart kid in school, and they move on from that. And art has always been sort of been left to the side.
But I think you're really talking about the effects of schooling. And I mean, you could easily, and it narrows or often, but you could equally talk about the young child as a scientist, as Piaget did.
I think children are natural scientists. They're curious. They ask questions.
Sure.
Scientists ask questions. Artists ask questions.
Don't think it's differentiated into a discipline
I don't think
yet.
you can express what you feel about science until you have other language, other tools, language, numbers. You can express how you're feeling
Right.
artistically.
Yeah, we need to stop. I do think that this is so fascinating, though, because it's getting at the whole question of interdisciplinarity and, what are the values of the disciplines? When do we need them, and when do we need to blur the boundaries between them? So, do we have to stop, or can we take this one question in the end that looked like he really, really wanted to ask it?
Well, I think several people probably want to go upstairs to see the exhibition.
Okay,
I'm sure the three of you will be sticking around a
Sure.
little bit longer.
Sure.
So if people have questions. we can go on
Great.
more speakers. But thank you to the three of you.
thanks for coming.